We are going to do an introduction to the Firefly Semantics Slice Entity Store. We are going to be covering data modeling, store initialization, entity ID assignment, store observation, entity comparison, store querying, core API methods, utility API methods, and slice creation. In the description below, we've provided a link to a written tutorial that goes along with this guide and a Stackblitz environment that we're going to be demoing the code samples from. We're also going to show you how to create your own Stackblitz. That way, if you want to copy over snippets and play around with them, you have an environment to do that in. All right, here we are on Stackblitz. Go ahead and click on TypeScript. And in the dependencies field, type in @Firefly Semantics Slice, and then click Install Missing Dependencies. And now you have your own playground that you can use to copy in the snippets. All right, here we are in the Stackblitz that we've linked to in the description below. And the first thing we're going to do is create a to-do interface for the to-do entities that we're going to be storing. As you can see, we've provided a global ID property, and this is assigned by slice. It gives each entity a unique ID that is local to slice. As we can see here, we also have an ID property, and this could be used, for example, in a chat client where the chat messages are created by slice and assigned a unique global ID within the first originating client. And when the server receives the message, it also assigns the ID property. That way, the message is now uniquely identifiable both on the server and on all the clients that the message is being sent to. In order to have a data set to work with, we're going to go ahead and create two to-dos. The first one, the second one, and we'll also create an array with these to-dos on it so we can demo adding an array to each entity store. We're also going to create two string key variables that we are going to use to provide a unique ID on each entity. That way we can look up the entity on the store using the findOneById API. In order to create a store, we're going to create a store variable, and we're going to type it eStore with a generic type of to-do. And we're going to assign that to a constructor that is of type eStore with a generic type of to-do. And we're also going to pass in the array of to-dos that we created up here. And that is how you create a new store. Now that our store is populated, we can go ahead and look up our entities by ID. And we do that using findOneById. And so we'll pass in the first ID here, and that gives us the first entity. And we'll pass in a second ID here, that gives us the second entity, and we'll go ahead and log them just to show you that we are getting our entities back. And here we have the first entity. It has an ID of 1, and it also has a global ID that is assigned by slice. We can also query for to-dos using a predicate function, and here we're going to demo that by passing in a predicate function that looks for all of the to-dos with a title length greater than 10. We will go ahead and console log that so we can see what it returned to us. And in this case, both of the to-dos have title lengths greater than 10. And so we see that they're both logged here on the right-hand side. In order to fetch all the entities in the store, we can call allSnapshot. And here we're going to go ahead and fetch all of the to-do entities in the store, and we'll console log the result like that. And we can see that we have an array containing all of the entities in the store. In addition to fetching entities using findOneById or select, we can also subscribe to the store's observable, and this will give us reactive notifications when we first subscribe and anytime we perform a post, a delete, or a put on the store. We'll go ahead and activate our subscription, and we'll see up here that the first time it fires, which is right when it's activated, it logs the initial set of entities in the store. We then perform a post on the store, adding another entity, and we can see that we now have 3 entities in the store. And after that, we perform a delete, deleting the first entity in the store. And after that fires, we see that there are now only 2 entities left in the store, the second one and the third one. Finally, we update an entity and perform a put, and we can see that after that operation, the subscription fires again, and our entity has now been updated. We can compare entities by ID, and here we'll go ahead and use equals by ID to compare to-do 1 to to-do 1, and we'll console log the result. And we can see here that to-do1 does indeed equal to-do1. We can also compare entities by global ID. So here we'll call equals by global ID on T1 and T2. And when we log the results, we see that to-do1 does not equal to-do2. The way we add a single entity to the store is we perform a post. And so what we'll do here is we'll go ahead and create a new store, and then we'll post to-do1 to this store. And let's go ahead and uncomment the login section so we can see that we now have a store and that to-do has been added to it. If we want to add an array of entities to the store, we can go ahead and use post A. And so what we'll do is we'll create a new store, and then we'll call store3 post A to-dos, passing in our to-dos array. And just to see that that has now been added to our new store, we'll go ahead and console log the result. And we see that we have 2 entities within our store. Sometimes we have entities and they're not in an array and we just want to add them separately. We can do that using post n. So we'll go ahead and create a new store. And then we'll do store4 post n. And here we have the first entity and the second entity separated by commas. And just to show that they're added to the store, we'll console log the result. And here we see the store contents are added. We have 2 entities in the store, and that's how we add multiple entities that are not in an array. In order to update an entity, we use a put. So in order to demo this, we'll go ahead and create a new store, store5. We'll post to-do1 to store5. We'll go ahead and fetch to-do1 from store5. Then we'll update the title, and we'll go ahead and perform a put on store5, putting to-do1 back into the store. And then we're going to console log the result to see that the updated entity is now in the store, and we see that we have a to-do that has been updated in the store, and that's how we update a single entity in the store. To update the store with multiple entities that are not in an array, we can use put n. And so to demo this, we'll go ahead and create a new store, store7, and then we'll look up both of the to-do entities in the store using find one by ID. So we have one here, we have one here. We're going to update the title of both of these to-dos, and then we'll use put n to put the 2 to-dos back into the store. And we'll go ahead and console log the result. And we can see that both of the to-dos have now been put back in the store. They are updated, and that's how we update the store with multiple entities that are not in an array. In order to delete an entity from the store, we're going to use, you guessed it, delete. So to demo this, we'll go ahead and create a new store. We'll post to-do1 to it. We'll look it up by ID, and then we'll delete it. And finally, we're going to console log the result to show that the store is empty. And as we can see, we get an empty array here, and that's how we delete an entity from the store. If we have an array of entities that we wish to delete, we're going to use delete A. And so to demo that, we'll go ahead and create store9, and then we're going to look up T1 and T2 from the store, and we're going to call delete A on store9, passing in the array of T1 and T2. And when we console log the result, we're going to see that the store is empty, and as we can see here, the store is still empty. To delete multiple individual entities that are not in an array, we can use delete n. And so to demo, we're going to go ahead and create store10. We'll look up both of the to-do entities in the store, and then we'll call delete n, passing in T1 and T2 without using an array. And so to demo this, we'll go ahead and console log it, and yep, our store is still empty. All right, we've covered all of the core API methods, and now we're going to cover a few utility methods. And the first one we're going to cover is toggle. And toggle will add an entity to the store if it's not already in the store, and remove it from the store if it is already in the store. So let's go ahead and create a new store, and we'll call toggle adding to-do1 to the store. Now, if we log the contents of the store here, we see that it added to-do1. Now we'll go ahead and comment that out, and we'll call toggle again. And if we now log the contents of the store, it should be empty because we called toggle twice. So we go ahead and log the contents, and we see that the store is indeed empty. And that's how we use toggle. Utility API that we're going to cover is the Active API. And an active entity is an entity that is currently active. For example, we might be working on a social app like Facebook where we have multiple active users. And we could have a collaboration scenario where we are working on multiple to-dos and the ones we are working on are currently active. And so what we're going to do here is create a new store called store active, and we're going to initialize it with our to-dos array. And then we're going to look up the two to-dos in the store, and we're going to go ahead here and add the first to-do as an active to-do. And when we do that, we can go ahead and console log the result. And we see that that to-do is now being marked as active. And if we add another to-do and go ahead and console log the result, we can see that there are now two active to-dos in the store. Now let's go ahead and comment out these console log statements like that, and so we don't get any noise when we refresh the store. Now what we can also do is we can delete a to-do as being active, and when we console log that, we see that the store now only has one active to-do. And we'll go ahead and comment that out again and delete the last active to-do, and now we see that there aren't any active to-dos. And so that's how we work with active to-dos using snapshots. We can also observe which to-dos are active by subscribing to observe active, and that's something we have done down here. And so we're going to go ahead and comment out the previous console log statement like this. And now we're going to take a look at what happens when we observe active to-dos. And so we have a console log statement here, and we can see that currently there aren't any active to-dos being observed. Now, when we go ahead and add a to-do as being active, first we got to comment out our delete active statement so that we don't nuke the active to-dos. And then we'll go ahead and clear our console and do this again. And now we see that we're observing one active to-do. If we add the second to-do, like that, we can see that we now get two console log statements. That's because the store is now notifying us that we have two active to-dos. And so that's how we observe which to-dos are active and which are not. So if we go down here, for example, and delete the first active to-do, now there is only one active to-do left in the observable array. So that's how we work with active to-dos. And one thing to note is that whenever we emit active to-dos, we emit them as a map. And so we converted that map using array from here. And so we took the active.values, which are the entries in the map, and converted that to an array using array from. So that's how you work with the active utility API. We can count the number of entities in the store, and to demo this, we'll go ahead and create a store called store count, and we're going to pass in our array of to-dos, and then we're just going to log the snapshot of the current entity count. And so you can see here on the right hand side, it logs the count snapshot is 2, and that's because we've called count snapshot on store count, and we have 2 entities in the store. Another thing we can do is observe when the store is loading, and this is useful, for example, when we want to fetch some data and display a loading indicator. So we're going to go ahead and create a loading observable down here by calling observe loading on the store that we're using, and then we're going to subscribe to the loading observable, and I'm just going to go ahead and console log whether the store is loading or not, and by default loading is true. So we can go up here and we can set loading to false on the store, and now we can see that the observable is logging false. So that's how we observe whether the store is loading or not. As with store loading, we can also observe when the store is searching, and this is used, for example, when we're fetching some data via search API and we want to indicate that the store is searching using a spinner or some other indicator. So we'll go ahead and observe our searching observable down here, and when we set searching to true, we see that true is logged, indicating that the store is searching. And if we set it to false, then we see that false is logged because the store is no longer searching. So that's how we observe whether the store is searching or not. Another thing we can observe is a query. And this is used when, for example, we are querying for something specific related to the store and we want to associate that with the store. And so we'll go ahead and create a new store called store query, and we'll set the query to slice is awesome. And then we'll create a query observable down here, which is an observable typed as a string, and we'll observe that query. So now when we hit refresh, we see slice is awesome, and that is coming from our console log statement that we get in our subscriber. So that is how you tie a query to the store. We can check whether the store is empty by calling isEmptySnapshot. So we'll create a new store called storeEmpty, and then we'll console log isEmptySnapshot to see whether the store is empty. And it is empty because we didn't initialize this store with any to-dos. We can also monitor whether the store is empty using an observable, and we get that observable by calling isEmpty on the store. And we're going to go ahead and console log whether it's empty, and so when our subscription fires, we see that the store is empty. And so that's how we monitor whether the store is empty or not. We can also reset the store completely. So to do that, we'll go ahead and create a new store called store clear, and we'll call reset on store clear. And we can reset the store completely. We'll create a new store here called store reset, and we'll pass in our to-dos. Then we'll call reset on it, and we should now see that this store is empty. So we'll go ahead and console log empty, and we see that it is empty. And so calling reset on the store has completely emptied it. If you want to see whether the store contains an entity, we can call contains on the store. So we'll go ahead and create a new store called store contains, and we'll pass in our to-do array. And then we'll go ahead and grab T1 and T2, which are the two to-dos in the store. And we're going to console log whether the store contains T2. And so when we do that and we hit refresh here, we see that it's true. So the store does contain T2, which is the second to-do. All right, the last feature we're going to talk about is slices. And slices are dynamic reactive filters that we can add to the store. And we are going to add two of them, one for complete slices and one for incomplete slices. And so we'll go ahead and create a new store, and we'll call add slice, passing in the complete key here and the predicate function that filters to-do entities that are complete. And the second slice we're going to add is the incomplete slice, and the predicate function for that will filter for incomplete to-do entities. And to check that this is working, we'll go ahead and console log the contents of the first slice, the complete slice. And the way we get the entities that are stored in it is by calling all snapshot on it, and that'll give us the complete to-dos, and then we'll console log them here. So let's go ahead and do that. And we see here that we have a single entity in that slice. It has an ID of 2, and it is complete. So that's that one. And to check that our incomplete slice is working, we'll go ahead and do the same thing. We'll get the slice here, and we'll call all snapshot on it, and then we'll console log the contents. And we can see that that slice contains one entity, and complete is false. So now that we see that now we can see that our slices are working. And the last thing we're going to do is go ahead and observe the completed to-do slice. And the way we do that is we go ahead and get the observable that is bound to that slice, and then we can go ahead and log the contents. So we'll go ahead and subscribe to the observable right here, and then we'll console log the contents like that. And we can see that there's a single to-do inside that slice, and we are receiving the notification that it's in there when we first subscribe. Now, what we can do also is assign another to-do to the store, like this. And now we see that first we get a notification that the to-do that is complete is already in the slice. But since we added another to-do that also has complete set to true, that has been added to the slice dynamically when we assigned it to the store. And so that is the slice feature. And we're going to make another guide on that a little bit later too, to demo how it's used in applications and so on, to give you a better idea of the use cases for them. And that's it. I hope you enjoyed this tutorial. Please remember to like and subscribe. And if you have any comments, questions, or feedback, we would love to hear from you. Have a wonderful day.